Assalamu alaikum guys, my name is Arsalan Farrukh and I teach math and physics. In this video, I will try and explain how to determine the areas of triangles using their coordinates. So you can get into a situation where you have to find out the area of a triangle, and if you look at that triangle closely, one of the sides are either parallel to y-axis or parallel to x-axis. In such case, you will consider that side which is either horizontal or vertical as the base, and then use the formula area equals half into base into height. Like if I look at this triangle and I consider this side as a base, this is a vertical side. So the base of this triangle would be equal to the difference of these y coordinates, 4 minus 2. And hence the base of this triangle comes out to be 2. And then I would find out the height. Height will be the distance from the base to the highest point, and that will be this length. And this I can find out by finding out the difference of the x coordinates. So if this is -1 and this is -4, the difference is going to be 3. So, and the area of the triangle is going to be half times 2 times 3, and that's how I can get myself the area. Similarly, if I look at this other triangle, this is going to be the base, and to find out the length of the base, I can take out the difference of the x coordinates because it's parallel to x-axis. So it will be 5 minus 1, which will be equal to 4. So the base is going to be equal to 4, and then to find out the height of the triangle, I will find out the difference of the y coordinate from the highest point to the base, and that's going to be 7 minus 1, which will be 6, and then I can use the formula half into 4 into 6, and that gets me the area of the triangle. That's coming out to be 12. There is another way to find out the area. There's a little longer way by using the modulus formula, but this formula is effective even in situations where you have one side either horizontal or vertical. You can still use this particular formula, where the formula goes like half, you make a modulus sign, and then vertically you write down the coordinates of the triangle. So you write down the first coordinate and the second coordinate and then third coordinate, and then lastly you write down the first coordinate back again. And preferably you should write these coordinates in an anti-clockwise order. So if you write down the first coordinate, then you take this next coordinate while moving in an anti-clockwise order. Although it wouldn't make much of a difference, the only difference is going to be if you take your coordinates in a clockwise order, then you will get a negative answer. You can just discard the negative sign and still you will get the correct answer for the area. So you write down first coordinate, second coordinate, third coordinate, and then after that you write down the first coordinate again. And then you will multiply the elements of the leading diagonal, like this, x1 into y1, x2 into y2, and x3 into y1. Half is still outside, and this is going to be your first product, first set of products in their sums. Then you put a minus sign, and then you multiply the elements in the lagging diagonal. That means x1 into y3 plus x3 into y2 plus x2 into y1. All of them are being added and then subtracted. And once you will simplify this entire thing out, as there is a modulus sign, if you get a negative answer, which I've already told you would get in situation if you had taken it in a clockwise order, so you would just discard the negative sign and multiply it by half, and you will get yourself the answer for the area. Let's take an example. Like I have been given this triangle and none of its sides are either horizontal or vertical, so I would not be able to apply the first method to find out the area. So what I can do is that I can just write half, and then I can choose any coordinate. I mean, I can choose any of the coordinates as my first coordinate and then go in an anti-clockwise order. So if I've chosen -1, then the next coordinate I would write as 3, 1. Then the next coordinate would be 1, 3. And then after writing down the 3 coordinates, I will rewrite the first coordinate again. And then how would I simplify this? Multiply the elements of the leading diagonal. That's going to be -1 into 1 gives you -1, 3 into 3 gives you 9, and 1 into -1 gives you -1. Then you put a minus sign in between and then you multiply it in the lagging diagonal. So minus 1 into 3 plus 1 into 1 plus 3 into minus 1, and that is the product and sum of the lagging diagonals. You just simplify these, like you open this up, 9 and minus 2 becomes 7, and similarly minus 3 is minus 6 plus 1 is minus 5, multiplied by another minus outside becomes plus 5. And then you simplify this, 12 upon 2, and that gives you 6 squared units as the area of this triangle. If you ever get a negative sign after your overall result inside the modulus sign, just discard that negative sign and you will still get your right answer. Also, please notice that sometimes you might get a quadrilateral or a parallelogram or a rectangle. The same method could be extended to a figure with more number of sides. So you can extend it to like 4-sided figure or 5-sided figure or 6-sided figure. So if it has another coordinate, you just, after writing down these 3 coordinates, you can write down the 4th coordinate or maybe a 5th coordinate. And then you just have to just make sure that you write down the first coordinate back again, and then you again multiply leading diagonals minus lagging diagonals, and that will give you your answer. Don't forget to write a half, even if it's a triangle or a trapezium or a rectangle. I mean, any sided figure, the formula has a half outside. Now, the other thing that you could be using in some certain situations is where you have to find out the ratios of the areas of triangles. And obviously bear in mind, you can obviously find areas and then divide the areas to get yourself the ratios of areas, but you can also directly get the ratio of areas of those triangles without even having to find out the areas entirely. And that's what we are focusing on right now. Like, for example, if I would look at this particular figure, I can see that there are 2 triangles, and since BC is parallel to AD, EBC triangle is similar to EAD triangle. Now, for instance, if I have to find out the ratios of the sides BE and AE, I have to find BE divided by AE. And of course, you know that if you're going to go for this particular thing, you're going to have to go by a very, very long process to find out first the coordinate of E. And that's a long process, because to find the coordinates of E, you will have to first find out the equation of the line AB. Then you have to find out the equation of the line CD. After getting the 2 equations, you will have to solve them simultaneously, and then you will get the coordinate E. And then once you will get the coordinate E, then obviously you would have to apply distance formula again on BE and AE, and then divide them to get yourself the ratio. And the technique that I'm going to be telling you right now is going to be very helpful to get this ratio directly. So what you can do over here is that if you have to find BE over AE and you have realized that these two are similar triangles, so you can say that BE divided by AE is same as BC divided by AD, because these are similar triangles. So for similar triangles, the ratio of the corresponding sides are always equal. And once I've realized that it is equal to that, I can just directly do BC over AD. Now, if I would do BC over AD to find out the ratio of the sides, now my length of working has really shortened here, because I can just get myself the length BC by applying the distance formula. I don't have to find out the coordinate of E now. I'll find the length BC, I'll find the length AD, and I can divide them and I can get my answer directly. But there is also even a shorter way of achieving this, and that is by using the line segment BC, you can make a horizontal and vertical line. And similarly, by using the line segment AD, you can again draw a horizontal and vertical line. And then you will realize that this triangle is similar to this triangle as well. So the ratio of BC over AD is same as the ratio of this length over this length. for which you don't have to apply the distance formula, because this length over here must be equal to just the difference of these x coordinates, like 12 minus 3, and hence this length must be equal to 9. And similarly, this length must be equal to, again, the distance of the x coordinates. That's going to be 15 minus 0, and that should be 15. I could also have done this by finding out the ratios of the vertical sides as well. It should give me the same result. So if I would do that, the BC over AD is going to become 9 over 15, and that's going to be 3 over 5. So that's how easily I can get the ratio of the sides. You can just imagine if you had gone through that entire working of finding one equation, finding the other equation, solving them simultaneously, it would have taken you a lot of effort and working, and again increasing your chances of making a mistake. And if I have to find out the ratios of areas of the triangles, I can easily now find that out by using the fact that the ratios of areas of triangles are, for a similar triangles, are equal to the square of the ratios of triangle. I can use the fact that for similar triangles, the ratio of areas of triangles is equal to square of the ratios of corresponding sides. So if I have to find out the area of BCE over area of ADE, I can just use their corresponding sides. So I can say that will be BC upon AD, and that whole thing being squared. So that's going to be 3 over 5 whole square, and I can simplify that as 9 over 25. Not just that, if I have found the ratios of similar triangles, now I can use that to also find out the ratio of triangle and trapezium. So if I have to find area of triangle BCE over the area of ABCD, that is the trapezium, I can also find that because the triangle BCE has a ratio 9, and the trapezium ABCD should have a ratio 25 minus 9, and that should be 16. So I can get myself this ratio as 9 over 16. So I can get the ratio of this trapezium and this triangle. And can you see that how helpful would that be as well, that if you can now use that modulus formula to find out the area of trapezium and put it here, you can get the area of this triangle as well without even having to find the coordinate E. And not just the area of this triangle, if you can get the area of this triangle, I can add the area of trapezium and I can get myself the whole area as well. So let's see, if I have to find the area of ABCD, that's gonna be half, and then I start writing down my coordinates. That's gonna be 0, 2, 15, 7, 12, 16, 3, 13, and then I write down the first coordinate again. That's going to be 0 and 2. And then I'm going to open this up. That's going to be half. 7 times 0 is 0, plus 16 times 15, plus 12 times 13, and then minus 0 times 13, plus 3 times 16, plus 12 times 7, and plus 15 times 2. So if I would find this thing, I will be able to get myself the area of ABCD. And if I know area of triangle BCE over area of ABCD, so if I put area of ABCD, that I'll find from here in this equation, I'll be able to get the area of the triangle BCE. So I'm getting this area as 855 squared units. So if I'm getting area of ABCD as 855 square units, I can find out area of triangle BCE, and that's gonna be 9 by 16 times 855 by using this particular equation. And once I get the area of triangle BCE, I can also add the area of the trapezium to get the area of the whole big triangle as well. So I can calculate all of the areas involved without having to find out the coordinate A. So guys, I hope this video was helpful towards finding out the areas and ratios of areas of triangles. If you liked the video, please give a thumbs up and share. Thank you.